Welcome to today's PAVE virtual panel entitled Driverless Car, Horseless Carriage, Seeing AVs Beyond the Car. Throughout history, humans have seen new technology through the lens of what came before it, such as when the first cars were called horseless carriages. That representation can often limit our understanding and our expectation for new technologies, and is a phenomenon that autonomous vehicles face as well. When we think about autonomous vehicles purely as cars like we know today, just with no driver, we can limit our understanding of the potential and applications that might be possible with autonomous vehicles. In today's panel, we're going to look at how our understanding of cars shapes the view of AVs and how we might be able to begin imagining AVs as more than just driverless cars. My name is Tabitha Coulter, and I'm PAVE's Director of Operation and today's moderator. With us today, we have three guests. First, we have Adam Campbell, Senior Manager of Safety Innovation and Impact at Gatik. Adam, great to have you with us.
Pleasure to be here. Thank you.
And second, we have John Lunneman, Senior Principal Engineer at Toyota's Collaborative Safety Research Center. John, thanks for making the time today.
Thanks for having me.
And our third guest is Joseph Putney, VP of Commercial Systems at RRAI. Joseph, thanks for being here.
Thanks for having us.
Awesome. So before we kind of start talking about that new technology behind autonomous vehicles, I think it's helpful to start with where we are today and how we think about cars now. So let's work to deconstruct the idea of a modern car. What are the aspects of cars that are the most fundamental to how we use them? How has this image been created and influenced in the years since we first transitioned from horses to motor vehicles? John, I'd like to start with you on this one.
Sure. Actually, I think that image has a long history, just rooted in transportation modes well beyond before cars. Maybe ever since man started traveling beyond means of just walking, right? And that is that ever since beyond walking, we've always had to essentially control our transportation using longitudinal and lateral control measures or means, right? In cars, it's the brake, accelerator, the steering wheel, right? But even before that, with horses or other animals we may have ridden on or bicycles, we're always controlling our longitudinal, direction and lateral control. So I think it's really rooted in that. It's really all about longitudinal and lateral control of whatever the vehicle, the devices that we're traveling on. And it's been that way for centuries, right? And just recently, right, in the last 100+ years or so, we've had vehicles. And even in the last 100 or so years, we haven't seen much change. There has been some change. We saw, cruise control was introduced in the 50s or so. But even that wasn't a really quick introduction. It took decades really for cruise control to eventually see a car. There were attempts to try to get some sort of speed control integrated in some way, shape, or form by use of governors, for example. It wasn't always through like a vacuum controlled cruise control system. But that's really it. There really hasn't been a lot with regard to vehicle control that's deviated from lateral and longitudinal control. Maybe a little bit in aerospace, a little bit in aviation, maybe some other industries, but they're very specialized, unique situations, unique scenarios. So I think that's really kind of the root of it all.
Absolutely. Adam, Joseph, anything to add there?
Yeah, I think one of the interesting things is, your commuter vehicle, you spend a lot of time, a large portion of your day in a commuter vehicle, and that's very central to how you think of autonomy and ADAS and all those capabilities. But I think what's really apparent, especially within the last year, is that with the supply chain issues, with ships off our coast, waiting to get into the ports, with prices going up, really there's a big impact that autonomous vehicles can have on things that we typically we take for granted, but is really in our face this year. And so there's a huge logistics machine, transport machine that's typically in the background that we don't see day to day, but now is a lot more clear. And that's really where a lot of the autonomy capability can really benefit the industry.
Yeah, I mean, I agree with the panelists sort of where we're at, and I think though it's interesting to think about what a vehicle is right now. The one that you can buy right now is sort of this it's this thing that is sort of the end point of optimizing to the greatest extent possible all different types of constructs: safety, performance, efficiency, price. It's sort of what can be built for what people will buy. It's certainly not what is available today, the safest possible structure of a vehicle that you would ever imagine constructing if price wasn't a limitation, right? So in that you can take that to the nth degree in every other type of example, whether it's performance or efficiency or style and what it looks like. So it's this fine balance that's been struck over time. And so, I think certainly where we're going right now with autonomous vehicles, what are we optimizing? The same sort of concept can be put into place now. What are we going to be optimizing for? What is going to be on the road? Is it for looks? Is it for safety? Is it for both? Because that will very much affect what is on the road and, ultimately what that vehicle or system is capable of doing.
If I can add something to that, we've had quite a bit of change already, with vehicles with regard to the user experience, with the looks, we actually are seeing a lot of safety benefits even outside of automated driving systems, a lot of safety systems that we've integrated. And the look and the feel, I think what we're looking at now, right, is a pretty dramatic change, and it's the loss of that lateral and longitudinal control that I think we need to illustrate and demonstrate to our users and our customers at some point, so that they're able to ultimately accept the system at some point in the future and understand how it works and ultimately trust and accept it.
Yeah, and there's another aspect of personal vehicles I think we hear reflected by the public a lot, which is kind of this go anywhere, serve any trip nature of cars, which is kind of part of this explanation of how people think of, car ads that show the freedom of the open road and being able to use their personal vehicle for almost all of their daily needs. And that's a big distinction, I think, between cars people are owning today versus autonomous vehicles that we're seeing being tested and deployed. Joseph, could you talk a little bit about why so many AVs are being developed to drive only in certain environments or roadways, also known as that level 4 automation?
Yeah, sure. So one of the big reasons for pushing that way is basically the functional safety requirements. How do you prove that a vehicle is not only achieved the level of safety, but can prove that level of safety? And so because of that, people are a lot of different companies are pivoting toward limiting the use case so that you can constrain the problem and provide a solution to safety for that particular problem. One of the challenges, though, with that is you do have to balance, there is a delicate balance there between providing ample capabilities so that you're not providing a niche product, so that it is usable in the long run. One of the examples, for example, that a lot of the industry is moving toward is the OTR application, OTR trucks, where they're transporting material on roads. And one of the reasons they are focusing on the hub to hub is because they can make a lot of assumptions about road characteristics, lane markings, the flatness of the road. But while that improves your ability to address functional safety, it does limit your technology to that particular niche and limits your ability to use that same vehicle in a yard or in mixed traffic and things like that. So there is a delicate balance, and that's one of the main reasons why RAI is focusing on a variety of different industries, so that we're not only minimizing focusing on use cases where functional safety is lower hanging fruit, but also that we have capabilities in the yard for the yard trucks, or on highway and off-road with the Class 8 trucks, or on bus rapid transit with buses.
Yeah, no, it's interesting that you say that, Joseph, and I hear that perspective when the sort of endpoint goal is to have the sort of go anywhere at any time autonomous vehicle. When we think of the personal autonomous vehicle, you want it to be able to go to school and work and somewhere in between and back. The niche concept, though, is actually and can be used to an AV company's advantage, and I think that's something where Gatik is uniquely positioned, and just, shameless plug, but like our whole intention is to build a product that only operates on fixed and repeatable routes. And that is precisely where our value exists. Stripping away all the complexities of the world and focusing and tailoring the technology to only one route or a fine selection of routes. I think it depends. So I guess the answer depends on what your intended use case is. If you want blanket broad adoption by the public, then there's sort of a requirement for capability across all domains and across entire environments. But when there is sort of that unique combination of commercial application and niche, sort of very refined use cases where autonomy can be helpful, that's a sweet spot. And I think there are many. Gatik is only one of many examples where that sweet spot does exist.
Yeah, I kind of want to comment on something you said there, Adam. And I think, correct me if I heard you wrong, but you said something about if your intent is to have sort of broad acceptance across a population, then you want sort of broad coverage and basically, paraphrasing here, operation, basically extending the ODD and the features and functionalities, right?
Sure.
And I don't know if that's necessarily the case. I would say, we all should understand that this is a growth process and we're moving towards higher levels of autonomy, right? And the goal is for as broad as possible, but there's there's a whole bunch of sub goals underneath there, and there's safety benefits that we can reap when we achieve those sub goals. So I don't know if the phrase look can't see the forest for the trees applies here, but I think it's important. I just want to add, I guess, that it's important to understand that we're growing the level of autonomy over time.
Mhm.
And that is a goal. If everybody can benefit from vehicle automation in all scenarios, all situations, et cetera, that's great. But I think we're targeting different levels and then trying to step up to that, if that makes sense.
Yeah, agreed. I think there's application and use and value at every stage.
Yep.
I think to your point, and depending
Yeah.
on who the end user is, and what the sort of ultimate endpoint is for that user is where the value is defined. So
Yep.
commercial applications, B2B applications, very different from consumer, like direct customer facing applications. So yeah, I'm with you. It's certainly breaking down those models and knowing that this is a stepwise approach to getting to go everywhere at any time. We need to hit milestones, obviously, in advance of that, but that's not everyone's goal, I guess, is the ultimate point there.
Sure. Yeah. And actually, the one thing I wanted to add, and I think that's really important if we want to get people to trust and accept it, right? So we need to be transparent about and realistic about what the technology does when we're communicating that to the end users.
And I wanted to build on an earlier point that both Adam and Joseph, you both touched on, which is, sometimes when we discuss autonomous vehicle technology, the focus stays on personal mobility, like passenger cars. But there's a lot of other applications out there, whether it's delivery or trucking or transit, that are also really appealing as opportunities for this technology, in part because of this level 4 kind of limited situation. So Joseph, could you touch on, I know you discussed a little bit those applications, but could you talk on that a little bit more broadly?
Sure, and I guess to kind of piggyback on John's comment that, it is very important to pick the proper operational design domain that we're running in, because there are lower hanging fruits than some of the longer term goals of, having autonomy work everywhere. And we've certainly approached it from that perspective. So just to give you a few examples, yard trucks, for example, they're operating at distribution centers, warehouses, port terminals, train terminals, basically moving trailers around from parking spots to loading docks, and we're talking about lower speeds. You're not operating in public mixed traffic. So from a safety perspective, it's an ideal location to be able to actually operate in a driverless fashion. And so we have several pilots running in 2 continents today in the yard truck space. On the bus side, there are several applications. The bus transit world is there's much demand for just ADAS level 2 capabilities or even level 1 capabilities. A lot of the focus has been on automotive and truck because of scale. But on the bus, those capabilities are really not existent. So that's a big need, but also we have several various pilots going on. We have a pilot with the Connecticut DOT to run autonomous buses. We worked on the first autonomous bus in North America, the New Flyer Excelsior AV, that's going to be running with passengers on the Connecticut DOT CT Fast Track Bus Rapid Transit line. And that system's acting on a dedicated lane similar to a light rail system. However, rather than connected train on track, it's connected bus on roadway. So from a CapEx cost, it's a lot lower, but providing the mass transit capabilities of light rail. And then on the Class 8 truck, we're doing a lot of work where there's a mixture of off-road to on-road. In the timber industry, the oil and gas industry, moving different aggregate timber, et cetera, between harvesting sites, like in the case in Canada, where we're harvesting wood and timber and moving those to mills. And then the same for the oil and gas industry. So there's a lot of different applications, off-road applications, while technically more challenging from an engineering perspective, from a risk perspective is a lot lower risk than on public roads. But so it's a low-hanging fruit in our eyes, and it's a way that we can realize a lot of this technology earlier than later, and then ultimately provide value to every citizen, because as we see today, supply shortages are a huge issue, whether it's timber or toilet paper, as maybe that's too soon, but for that.
Yeah, I just to build on that, Joseph, I think if you imagine however long ago it was, 5-10 years ago, where what was being sort of hyped up in the AV space was like how much can be done, how complex the environment, the AV, whether it's for yard purposes or for just so robo-taxi purposes, how complex the environment can be and be safely traveled through with some technology behind the wheel. Fast forward to today, and I think you brought up many great examples, Joseph, about stepping back from sort of, let's see how complicated the environment can be that we can operate in, and try and reduce this down to something that's manageable with the technology that's available today and provides commercial value, so that that wheel will keep turning, that you can keep investing in innovation and research and keep developing this technology. It's important. I think that's been a shift in the industry and in the ecosystem of autonomous vehicles in the last few years, and an important one, because it's allowed for even companies like Gatik and others who refine and constrain the use case to such a degree that you can rapidly deploy safe vehicles and provide commercial values all within a period of time that going everywhere at all times, it would be a much greater challenge. So I see what you're doing there, Joseph, and I think it speaks to the same sort of things that we at Gatik are seeing as being viable opportunities for AV technology.
And some of those points that you both were just discussing about autonomous vehicles kind of suggest some similarities to some traditional roles we've seen robots take. Robots have historically delivered value in simple, repetitive tasks that are hard for or hard on humans, things like lifting or welding. And they tend to do best when they might be a little bit more isolated, insulated from that randomness of human behavior. Love to just kind of tease that out a little bit more. So John, how might thinking of AV technology as similar to a robot versus a traditional human-driven car, how could that help shape that mental model, that image of how we think about this technology?
Yeah, I don't know if thinking of automated driving systems as a robot fits here. Maybe this isn't the right domain. One thing to note, ADSs, automated vehicles, they do seem robotic right now. That's because they don't have a lot of human-like characteristics or traits integrated into them. But it's important to remember that safety is a priority. So their behavior is predicated on safety, and there's not a lot of human-like characteristics integrated into that. And I mentioned that because I read an article, and I've been doing some research in an area called roadmanship. First read about it in an article by Rand, I think in 2018. And roadmanship is really the idea that an automated vehicle should move beyond safety. So safety is important, but we also need to consider courtesy. When we drive, we don't drive just thinking, okay, how safe am I? And that's enough. There's oftentimes that we're thinking, not only am I safe, but I'm not a jerk to the person to my side or behind me, or vice versa. These people around me are driving, like with a lack of courtesy, right? And so I think in the future, what we really want to focus on possibly is integrating more human-like characteristics or traits. And that actually fits with my discipline as a human factors psychologist, engineer, is because we're always supposed to design technology so that it fits to the human. Well, what fits better with a human than another human, right? So I think that fits common human factors design approaches. There's some research we did with a company called Westat in the past. We did some mental models research, and won't get into the details of that, but we did learn that terms like machine, for example, don't necessarily foster positive trust and emotions towards vehicle automation. Instead, we found that terms like assistant tend to be more conducive to facilitating trust and emotion. And that's, we actually found a cohort of different types of learners, and these are what we call misinformed learners. And they are people who, when they think of vehicle automation, they don't understand it, but they think they do. And they're our stubborn group, right? They don't want to learn about it and they don't want to use it. And interestingly, the number one term we found that they use to describe vehicle automation is it's a machine. So.
That's really fascinating. Joseph, I saw you nodding along a little bit there. Did you want to comment on that?
Yeah, there's actually some really interesting, the interaction with the, I guess not the robot as John says, but the autonomous vehicle and humans is really interesting. We were first getting into the robo shuttle industry, I don't know, 8 years ago. We found some very interesting characteristics. One, people change their behavior based on the time of day. More aggressive when they're hungry and tired at the end of the day than they are during the early parts of the day. A lot of this stuff manifests in places like intersections where there is interaction between all the different entities that are operating in that intersection, and people take cues on a lot of different things that you wouldn't really expect from as an engineer. For example, how long do you wait at a stop sign really conveys intent to all the people that are in the intersection. If you wait too long, basically you're telling them that you're going to wait for them to take precedence. And there's all kinds of things like, how do you steer the vehicle? Do you kind of lean a little bit left when you go into the intersection so people know that you're going to make a left, because they don't always look at turn signals and things like that. So there's a lot of interesting dynamics. But saying that, in the ideal world, we shouldn't be trying to design autonomous vehicles to adapt to human processes. In the ideal world, the autonomy has strengths and weaknesses that are different than what humans have strengths and weaknesses. And really, we should be designing systems around what autonomous vehicles are strong at. Now, saying that we have to be realistic and pragmatic. There is a lot of existing, for example, in the yard truck space, there's these issues with glad hand airline connections between trailers and trucks and things like that. Very much designed around human operation and not for autonomy. But these trailers are going to last for 10, 15 years. It's going to be very long to move, to replace those with systems that are more reliable and cheap for autonomous systems. So, in the ideal world, we try to focus on how we can generate processes, hardware, capabilities that are better suited for autonomy, and that will more quickly allow for the adoption of autonomous capability. But then you also have to balance that with the real world, and there's a lot of equipment out there in the real world that it's not easy to change, and processes for that matter.
I just want to say I agree. Yeah, it's finding the right balance between vehicle automation and then integrating like the human-like characteristics. You know, an example, you mentioned intersections. I was thinking, so I have a colleague that's done a lot of good research, Josh Domeyer, in vehicle and pedestrian interaction. And one of the things he's shown is that when people pull up, they sometimes stop short. They do a little creep of the vehicle to indicate maybe to a pedestrian that, you know what, I'm thinking about going, or they stop a little bit harder to indicate like, you know what, it's okay for you to go. And they use these sort of kinetic type messages to communicate with pedestrians. And so what I should, if I could go back and rephrase that, to the extent that we can and we should, we can grab human-like characteristics and integrate that into vehicle automation so that vehicle automation is more seamlessly integrated with society.
Yeah, I'd just like to say, you know, like how ironic is it to think that we need people who understand people to properly design autonomous vehicles, right? But I think, you know, this is, you know, this conversation comes up often. I think it's important that, you know, sort of to take the step back, that these autonomous vehicles don't exist in a vacuum. They are among us, will be, and being more human-like is actually of benefit in some situations to convey all the indirect messages of intent and you know, these sorts of things on the road, but then also, as you say, to do the things better than we expect of people when the time is right. And so, yeah, I think while ironic, I think it's great that there are that folks that bring in that perspective to this conversation.
After we're designing them for human use, right? So, and the one thing to keep in mind though is we do need to avoid that uncanny valley, right? I think we've all seen some pretty creepy sort of robot android type simulations and devices, and they get this uncanny valley, too realistic, a little bit creepy vibe, and maybe that's a detriment to trust and acceptance and actual utilization of the technology.
Well, and now that we're talking about trust and acceptance, it actually leads me to the question I was kind of wanting to end the panel on, and timing wise, I think that's going to work out. But so at PAVE, we receive a lot of questions from our public audience on these topics. And one of those I'd really like to get all three of your opinions on came from a public sector audience member who said, they've seen surveys that people don't trust driverless cars. And they asked, how can we convince or ultimately persuade the public that autonomous vehicles are indeed safe? So I'd love to hear kind of all three of your takes on, is that the right question to be asking? How can we kind of address these concerns and trust and acceptance? And we'll start with you. Let's say Joseph.
Yeah, so I think a lot of it has to do with, having incremental approaches, not an all or nothing with the autonomous vehicles, and being pragmatic in the deployment of this technology. So pilots, for example, are extremely important. Like I mentioned, we're partnered with Connecticut DOT to operate autonomous buses and revenue service in Connecticut, and getting feedback from those users and making people feel comfortable with the technology. And the same thing applies with any industry, right? With yard truck pilots and making sure that the different employees are familiar with the technology and how it works and what the limitations are and what the strengths are and all those kinds of things, and just getting those capabilities out in the wild in a safe manner, in an incremental manner. I think it's very critical. And then once people realize the value, then it's pretty easy to want to adopt the technology, as shown with ABS systems and all kinds of ADAS solutions now that's pretty commonplace in the automobile market.
Great. And Adam?
Yeah, maybe just a different perspective. I think more than trying to prove out as important as it is to prove the technology that's on board these vehicles, I think as far as convincing the public about perhaps the need for why autonomy is being put on the road from a safety standpoint is to highlight all the weaknesses of human drivers out there, what makes us not so great for the task. I think there's a perception of performance that we have for ourselves that isn't exactly reality. The simple things like visibility, distance at night, and overdriving headlights. I mean, we do that all the time. We don't know the safety consequences of that because we rarely confront hazards that require us to hammer the brakes in those circumstances. But if you did, you'd realize very quickly that, you know, you are not going to be able to avoid that collision at 80 kilometers an hour under low beam headlights. That's just, it won't happen. But understanding our own limitations as human drivers, I think, is part of an education that we don't have. We don't know how bad we are in certain circumstances, and to know what could be improved upon with this technology and specific reasons for why this technology would be better from a safety standpoint would be perhaps a unique perspective, or a unique approach to justifying the reason for something different out there.
Great. And John, we'll end with you.
Yeah. Well, first, Adam, that's a good point. There's a lot of research out there that shows that people tend to overestimate their own driving skill. So it's really something we need to think about deeply. But I kind of, get cringe at the words convincing or persuading. I think a better way to put it is we need to illustrate or demonstrate the ways in which automated vehicles or automated driving systems are safe, right? And I think the way to do that is to be as transparent as possible about, the purpose, the process, and performance of the automated driving systems, of the automation. So why do you have it? How does it do it? And ultimately, how well does it work? Right. The one thing I think need to keep in mind is these are new technologies. A lot of people are experiencing these things for the first time. They've experienced automation, but not in an environment like driving, I think we need to take into consideration that people have previous experiences with other automation and other technology that may influence their perception. So think of computers, for example. Computers are glitchy. There's security issues. To what extent are people going to take their understanding and associated feelings and emotions, et cetera, about computers and apply that to vehicle automation? It's not a new concept. It's something called relational trust. And I think it's something we need to maybe think about a little bit more and try to understand how does that not just trust and acceptance, but ultimately utilization of the technology. The last thing I'll say, we can't forget about how important emotion is in our research at WestDOT, and even in a lot of marketing and advertising research. It's been shown that emotion is a big motivator for accepting and using technologies. And what we've found is that one's understanding of technology, their mental model complexity, et cetera, those types of things tend to be mediated through emotion before you ultimately see manifestations in trust and acceptance. So how people actually feel about a technology and sort of like the emotional valence is just critically important.
It's really interesting. Thank you, all three of for all three of you sharing your perspective. And that actually does conclude our panel. It went very quickly, but thank you, Adam, John, and Joseph, for joining us at PAVE and our audience today.
Thanks for having us.
Thank you.
Thank you.
PAVE is going to continue building out some of those topics today later on in the month, so be on the lookout for future conversations. If you want to follow up with PAVE or our panelists today, please reach out to us via our website at www.pavecampaign.org or any of our social media accounts at PAVE Campaign. We'll be sending a link out later today for the full recording of this on our YouTube channel and a link to our new podcast if you prefer to get your information that way. Thank you to the audience for attending, submitting questions, and spreading the word. We hope to see you for our panel next week. Have a wonderful rest of your day.